In this video, I am going to explain some problems by using properties of Laplace transform. First problem, find Laplace transform of t square into e power minus 3t. So here I am going to apply the property L of t power n f of t equal to minus 1 power n d power n divided by ds power n L of f of t, because the product of in the product of two function, one function is an algebraic function. So for that I am going to apply this formula. Solution: so L of t square e power minus 3t equal to, so the power for the degree for t is 2. So for that I am going to substitute this formula. Instead of n I am going to substitute 2. So you may get minus 1 power 2 d power 2 divided by d s power 2 L of e power minus 3t, L of e power minus 3t, which is equal to minus 1 square is equal to minus 1. So you may get d square by ds square L of e power minus 3. So you know the formula, L of e power minus at equal to 1 by s plus a. So I have applied. So you may get 1 by s plus 3. So instead of a, 3 is given. Now try to differentiate this term with respect to s twice. So now first I am going to differentiate. I am going to differentiate 1 by s plus 3. You may get, before substituting, try to rewrite this term like this. It is very easy to differentiate. So first differentiation, you may get minus 1 into s plus 3 whole power minus 2, which is equal to, again try to differentiate, because we are going to differentiate 2 times. I have differentiated 1 time, again try to differentiate. So from that you may get 2 into s plus 3 whole power minus 3, which is equal to 2 by s plus 3 whole power plus 3. So this is the answer for Laplace transform of t square into e power minus 3t. Second problem, find Laplace transform of t into e power minus 2t into sin t. So here, given that the function product of 3 function is given, right? So now I am going to apply this formula. This is the property, first shifting property. Second one is derivative. Third one is the normal formula L of sin at. I am going to apply these 3 formulas in this problem. So first one, so now I am going to write the given question, e power minus 2t sin t. So you can use this property. Now first I am going to apply. You can apply first between these 2 properties. You can apply any property, right? But now I am going to apply the first property. If you apply the first property, you may get Laplace transform of t into sin t. After finding this Laplace transform, you have to replace s by s plus 2. So here you get minus 2. So for that you have to put s plus 2. So you have to interchange the limit sign, right? Now I am going to take, this is equation 1. This is equation 1. Now I am going to find out separately t into sin t, Laplace transform of t into sin t separately. So now I am going to apply the second property. By using the second property, instead of t you can put d by ds L of sin t. Now you can apply this formula sin at L of sin at. So minus d by ds of 1 by a is equal to 1. So you can apply L of sin t equal to 1 by s square plus 1. So you can rewrite this term as like this, minus d by ds of s square plus 1 whole power minus 1. If you differentiate, you may get minus of minus 1 into s square plus 1 whole power minus 2. By using the chain rule, you have to differentiate s square plus 1 again. So if you differentiate, you may get 2s. So after the differentiation, you can get 2s divided by s square plus 2 whole power 2. So this is L of t sin t. So from equation 1, L of t e power minus 2t sin t equal to, you can apply equation 2 in 1. So from that you may get 2s divided by s square plus 2 whole power 2. After writing, you have to replace s by s plus 2. So from that you will get 2 into s plus 2 divided by s plus 2 whole power 2 plus 2 whole power 2. So this is the answer for L of t e power minus 2t sin t. Third problem, how to find Laplace transform of sin 3t cos 2t. So here there is no property to find the Laplace transform of product of two trigonometric functions. So for that I am going to apply some trigonometric identity. So we know that sin a cos b equal to 1 by 2 sin a plus b plus sin a minus b. So by using this formula, you can write product of two trigonometric function is equal to sum of two trigonometric function. So if you use this formula, you can split it. You can write as a sum of two trigonometric function. So from that, by using linear property, you can easily find Laplace transform. So that's why I am going to apply this formula. So here sin 3t cos 2t equal to 1 by 2 into sin 5t. If you apply the, you may get like this, sin t. So you can rewrite 1 by 2 sin 5t plus 1 by 2 sin t. Now try to take Laplace transform on both sides. So L of sin 3t cos 2t equal to Laplace transform of 1 by 2 sin 5t plus 1 by 2 sin t. By using linear property, you can rewrite this term as like this. By using the formula for L of sin at, you may get a by s square plus a square, which is equal to 1 by 2 5 by s square plus 5 square, that is 25, plus 1 by 2 1 by s square plus 1. So this is the answer for L of sin 3t cos 2t. evaluate integral over 0 to infinity e power minus t t sin t dt by Laplace transform. So here this integration is improper integral, so it is not easy to integrate directly. So for that, by using Laplace transform, it is very easy to integrate. So it is a main application, one of the uses for a Laplace transform. Sometimes they won't give this word, but you may apply the Laplace transform. So here we know the formula for a standard formula for Laplace transform. L of f of t equal to 0 to infinity e power minus st f of t dt. Try to compare the formula as well as the given question. So from that you can identify this is nothing but L of t sin t. After that you have to substitute s is equal to 1. So this is the meaning. So here in this problem s is not there. So that means they have substituted s is equal to 1. S is equal to 1. Right? So here, so you can rewrite this integral as L of t sin t, L of c sin t. After finding this Laplace transform, you can substitute s is equal to 1. So this is the meaning. Now I am going to find L of t sin t. L of t sin t. So which is equal to, I am going to apply the property. So in this function t is coming. So for that I am going to put minus d by ds of L of sin t s to s equal to 1. After finding Laplace transform, you have to put s is equal to 1 equal to minus d by ds of 1 by s square plus 1 equal to, if you differentiate, you may get minus 1 into s square plus 1 minus 2 into 2s, which is equal to, you can rewrite this term as minus, already one minus is there, so minus into minus it's going to be plus. So plus 2s divided by s square plus 1 whole power 2. After finding that the Laplace transform, you have to substitute s by 1. So 2 divided by 2 square, which is equal to 1 by 2. So finally you can get the integral over 0 to infinity e power minus t t sin t dt equal to 1 by 2. Find L of sin h 2t divided by 2. So in this function, t is, that means quotient, rational function is given, sin h 2t divided by t. Suppose the function t is divided in a original function, you have to use this property. L of f of t divided by t equal to integral over s to infinity L of f of t ds. If, when do you apply this formula? So it should be satisfy this condition. Limit t tends to 0, f of t divided by t equal to finite limit. Then only you can apply this property. Now I am going to apply that property here. Solution, I am going to write. So since limit t tends to 0, sin h 2t divided by 2 has a finite limit. You have a finite limit. So you may get a 1. So now I am going to apply that property. So limit sin h2t divided by t equal to, instead of 1 by t I am going to put integration, that's all. S to infinity L of sin h2t, it is a hyperbolic function, ds. So the Laplace transform of hyperbolic function is a by s square minus a square. By using the first formula, you can get 2 into s to infinity ds by s square minus 2 square. Now by using the third formula, you may get 2 into 1 by 2 into 2 log s minus 2 divided by s plus 2 and their corresponding limits, s to infinity. If you substitute s is equal to infinity in this value, you may get 0. So how? So simply, before substituting s is equal to infinity in this form, try to write log s minus 2 s plus 2 s log 1 minus 2 by s divided by 1 plus 2 by s, like this. I have taken s as a common term in the numerator of s minus 2 and s plus 2. So that means you may get like this. Now you can substitute s tends to s equal to infinity. So from that you may get this term, it's going to be 0. So finally you may get 1 by 1. That means log 1. Log 1 is equal to 0. So if you apply directly, we can't apply s is equal to infinity here. So from that you won't get, because log infinity by infinity we don't know. So for that, try to, before substituting infinity, try to convert like a 1 by s to 2 by s, like this. So from that you can cancel this 2 term. So 1 by 2, 0 minus log of s minus 2 divided by s plus 2, which is equal to 1 by 2. So instead of minus, you can interchange by using this property. Minus log a by b equal to log b by a. Instead of minus, you can interchange the numerator and denominator, which is equal to log s plus 2 divided by s minus 2. So this is called a Laplace transform of sin h2t divided by t. Suppose this term is not finite, you won't get a finite limit. Limit means you won't apply this property. So that means the Laplace transform of a particular function is not exist. This is the meaning. Evaluate integral over 1 minus cos 2t divided by t square dt by Laplace transform. By Laplace transform. Solution. So you can rewrite the given integral 1 minus cos 2t divided by t square dt as Laplace transform of 1 minus cos 2t divided by t square. After finding Laplace transform, if you substitute s is equal to 0, you may get this integration, original integration. So our first aim is we have to find Laplace transform of 1 minus cos 2t divided by t square. So now I am going to find a Laplace term. I am going to take this as equation 1. So L of 1 minus cos 2t divided by t square equal to, so here in this function we have multiplied 1 by t square. So a function which is multiplied by 1 by t square means you have to integrate twice of f of t with respect to s. That means instead of t 1 by t square, I am going to put 2 integration s to infinity, s to infinity. After putting these two integration, you have to take L of 1 minus cos 2t. So L of cos 1 minus 2t is nothing but s to infinity, s to infinity. If you take L of 1 is 1 by s, 1 by s. L of cos, this is a sum of a difference of two function. So you can use a linear property. So individually you can find a Laplace transform of 1 and cos 2t. So s by s square plus 2 square. If you find Laplace, you may get like this. Now I am going to integrate with respect to s first, which is equal to integral over s to infinity. If you integrate, you may get the integration of 1 by s is log s minus. So here by using this formula, integral over f dash of x divided by f of x dx equal to log f of x. So by using this formula, you can multiply by 2 and divided by 1 by 2. So from that you can use this formula. So from that you may get 1 by 2 into, if you differentiate s square plus 2 square, you may get 2s. That's why I have 2 is not there. So for that I have multiplied 2 and divided by 2. So now you can apply that formula. So from that you may get 1 by 2 into a log s square plus 2 square s to infinity ds. Only I have integrated with respect to s only. So one remaining one integration is there. Next one, before substituting here, after the integration, it's not possible to get the finite value. So for that, before substituting the limit s tends s equal to infinity, try to simplify these terms. After that, you can substitute s is equal to infinity, which is equal to integral over s to infinity. You can rewrite as log s square plus 4 whole power 1 by 2. I have multiplied 1 by 2 in the power. I have applied logarithmic properties. S to infinity ds, which is equal to s to infinity log a minus log b equal to log a by b. By using that formula, you may get square root of s square plus 2 square s to infinity ds. Now try to apply the upper limits. So keep in mind, a limit x tends to infinity log some f of x the same degree equal to 1 0. This is the formula. Try to apply this formula. The degree of f of x and g of x should be same, then only you may get the corresponding value. So by using that concept, you may get s tends to infinity. If you apply the upper limit, you may get 0. So minus log the lower limit, you have to get the same value of the function into ds, which is equal to integral over s to infinity. So instead of minus, I have interchanged that limit. That means a term log square root of s square plus 2 square divided by s ds. So which is equal to integral over s to infinity s to infinity. You can rewrite this term as square root of s square plus 4 divided by s square. So you can rewrite this term as like this. I have taken square root as a common term. Before that, I am going to simplify. I am going to include power 2 1 by 2. Right? ds, which is equal to, you can take s to infinity log s square plus 4 divided by s square. 1 by 2 you taken in the multiplication. So 1 by 2 as a constant you can take outside from this integration. Log, here you can take s square as a common term. If you take, you can rewrite s square plus 4 divided by s as 1 plus 4 by s square. 4 by s square ds, which is equal to 1 by 2 integral s to infinity log 1 plus 4 by s square ds. Now I am going to apply integration by parts. U dv equal to uv minus v du. So here I am going to take this term is u, ds is dv. So from that we will get 1 by 2. Now you have to find u dv. U dv is nothing but, if you differentiate, integrate a ds, you make it s only. So from that you make it s into log 1 plus 4 by s square and the corresponding limits s to infinity minus, if you differentiate log 1 by s square you may get integral over s to infinity. The differentiation of log 1 plus 4 by s square is nothing but 1 by 1 plus 4 by s square 1 by s square. If again you have differentiate, you may get minus 8 by s power 3 into dv. dv is nothing but, sorry, v is nothing but s. So s into ds. Right? So like this you may get the terms. You can cancel the remaining terms. Try to cancel. If you cancel you may get, so 1 by 2. Try to substitute the upper and lower limits. If you substitute the upper limits you may get this term, it's going to be 0. So for that, infinity into 0 you make it 0. So for upper limit, the first term is going to be 0 minus 1 by, already 1 by 2 is written here. So log s log 1 plus 4 by s square minus, you can rewrite this term after the simplification. You can rewrite this term as plus 8 by 2. I have multiplied 1 by 2 in the second integration. Integral s to infinity 1 by s square plus 4 ds. After multiplying, if you take the LCM of this term you may get 1 by s square. You can shift it to that term to numerator. From that you may cancel s power 2 in this corresponding term. Finally you make it like this. So the integration for this term is 1 by 2 minus 1 by 2 minus 1 by 2 equal to s 1 by 2 s log s square plus 4 divided by s square into plus 4 into the integration of 1 by s square plus 4 as 1 by 2 tan inverse of s by 2 s by 2 s by 2 upper and lower integral. Now after substituting the limits, you may get L of 1 minus cos 2t divided by t square is equal to minus 1 by 2 s log s square plus 4 divided by s square. If you substitute, you may get plus pi minus 2 tan inverse of s by 2 you may get. So in this expression, if you substitute s is equal to 0, so go through the equation 1, you have to substitute s is equal to 0 in the end of the Laplace transform. So from that, first term this is going to be 0, third term is also is going to be 0. So from that you will get, from first equation you have to substitute, put s is equal to 0. From that you may get 0 to infinity 1 minus cos 2t divided by t square dt equal to pi. So this is the answer.